Hello, dear students. Myself, Dr. Surekha Jaiswal, Head Department of Physics, Moreshwar College, VIIIModern. Now, today we will see X-rays, course code number 202, paper number 8, Modern and Nuclear Physics, semester 3rd. Now, see, contents are introduction, production of X-ray, properties of X-ray, application of X-ray and medical application. Now, introduction. X-ray were discovered by a German physician Roentgen in 1895. While studying the properties of cathode rays, he found that a very penetrating radiation was emerging from the discharge tube. He named their invisible penetrating radiation X-rays. They are also called Roentgen rays. Now, X-rays are produced when high velocity electrons are suddenly stopped by a solid target. They are electromagnetic waves just like ordinary light, but of much shorter wavelength, approximately 1 angstrom. The larger wavelength having low frequency. X-rays are low penetrating and are called soft X-rays, while the shorter wavelength having high frequency. X-rays more penetrating and are called hard X-rays. Now see production of X-rays. Now experimental arrangement, it consists of as shown in figure. Now this experimental arrangement here, that is a evacuated gas bulb that is made up of glass, and here F is a tungsten filament working as cathode, which is heated by a low tension battery. See in figure, that is filament, and here that is connected to battery. Now here also we have two electrodes, that is cathode and anode, as shown in figure. See, that is cathode terminal and that is the anode terminal here. Now this is positive terminal of battery that is connected to the anode, and negative terminal of battery is connected to the cathode, as shown in figure. Now this is there in figure, there is a window, from this X-rays are coming out. Now see here at the here anode, there is a that portion, that is a target, and that is deposited by a material like tungsten. Now here this is cooling tubes, cooling fins here. From this we allow the cold water, and from this hot water are coming out. Now electrons are thermionically emitted from cathode, is surrounded by molybdenum sheets kept at negative potential. So emitted electrons do not scatter, focus on target. See here target material. Now anode is here, that anode terminal is made up of any metal with high melting point, and here high melting point and high atomic number. And this cathode terminal is here, that is also made up of any metal over which we deposit thermosensitive material, and we can use that metal is tungsten. And this glass envelope is here, that is highly insulated, and it is made up of glass having high melting point, and its vacuum tight. Now target is massive tungsten block T kept at high positive voltage. It accelerates electrons towards T mounted on a hollow copper tube supplied by cooling fins to control heat produced during sticking of accelerated electrons on target. When switch is on, see here, when switch is on, then that filament is heated, and from this filament, from this heating coil, here electrons are emitting out, and that emitted electrons are here. See, electrons are thermally emitted and from cathode and is surrounded by molybdenum sheet kept at negative potential. So emitted electrons do not scatter, focus on this target, and that is here, that is the anode terminal. Now accelerated electrons strike on target and give up their kinetic energy thereby producing X-rays. Now properties of X-rays. X-rays are not deflected by electric and magnetic field, which shows that they do not consist of charge properties. Now they are electromagnetic radiation of very short wavelength, approximately 1 angstrom, and they allow photographic plate like light, but the effect is much more intensive than light. They travel in straight lines with the velocity of light, that is 3 into 10 raised to 8 meter per second. Also another property of X-ray, that is they produce fluorescence in several materials like barium, platinum cyanide, zinc sulfide, and cadmium tungsten. X-ray ionize the gas through which they pass. Also X-rays are highly penetrating and can pass through many solids, for example wood, flesh, etc. X-rays are opaque to ordinary light. They produce photoelectric effect and thus exhibit a corpuscular nature also. They show interference, diffraction and polarization similar to light rays. Now application of X-rays. X-rays are used to detect any defects in radio valves, tennis ball, rubber tires, and presence of pierce in oyster. X-ray can be used for testing the homogeneity of welded joints, insulating materials. X-rays are used to detect crack in structure in the body of aeroplane and motors, cars. X-rays can be used to analyze the structure of alloy and other composite body. The alloys like cobalt, nickel, steel, polysilicon, insulator have been analyzed. X-rays used for studying the structure of crystalline solids and alloys. X-rays are used in barcode scanner. Now see medical application of X-rays. The most common use of X-ray is to get photograph of interior of human body, and the photograph is known as radiograph. Another application of X-ray, it can be used to detect fracture, disease organ, foreign matters like bullet, and formation of stones in human body. Also application of X-ray, that is X-ray have curative properties and they are used to destroy abnormal internal tissue. They are also used to in the treatment of cancer, and also X-rays are used in to destroy tumors very deep inside the body. These are the medical application of X-rays. Thank you.